It's great to see some returning faces. We'll get started very shortly. So thank you all for coming and welcome to Gray Associates Masterclass 3 in Advanced Analytics. I would like to welcome our Gray panel, Chief Product Officers Zachary and Pete, and Gray Data Scientist Youssef. During this session, you will learn how to use predictive analytics to model the impact of program decisions on your institution's future. We encourage you to ask questions. Please take a look at the bottom of your Zoom screen. You can click on the Q&A and add your questions there. We will get to as many questions as we can during this session and will follow up later with you if we do run out of time. After the webinar, we will send out a link that will give you access to a recording of this session, as well as the session slides so that you can review them at your convenience. And now, without further ado, I will turn things over to Zach.
Great. Thank you, Marianne. Welcome, everyone. Pleasure to be here with you and my colleagues. Today, we're going to be looking at different applications of advanced analytics, ranging from budgeting and planning, operations and marketing, and academics. And let's jump right in to the first thing we'd like to talk about that is really focused on budgeting and planning, but also understanding what your value propositions are and what decisions students are making based on what you're presenting to them. And so the idea here is understanding what values of your program, your institution are an integral part of the decision-making process of a student. I get a lot of questions these days specifically around online education as an example. Should we be offering online education? What would that do for the demand for our program? Or how does pricing play a factor into the decision of a student decision-making process? Should we have a lower cost? Does having a higher cost make a difference? All of these questions are actually pretty complicated when you think about the decision a student is making. And so having a process to go through this to understand what are the most important value propositions to the student and how does that play into the cost and price of your program, as well as other pieces of your program that you want to highlight to make the most value to the student. So a couple of different things that you can do here. First and foremost is actually gathering the information and starting with who are your competitors. There's many different ways to actually get at this in terms of identifying who your main competitors are. First, you most likely have peer institutions that you've most likely had and kept track of and keep a list of on an ongoing basis. But there's other competitors that you might also want to keep track of. One way to do that is looking at the Department of Education data to really understand who's in your market, how large are they, and are they offering the same programs as you? So it's using the IPEDS data. A third one is looking at National Student Clearinghouse student tracker data. So you really understand for students who are applying to you, where else are they applying or potentially going instead of you? And so that's another look at who you're potentially competing with. Once you have that list, you really go through the detailed research of saying, okay, let's go to their website. Let's see how they're representing their program. Let's get an understanding of their cost so that you can start to collect the information that is required to do that competitive benchmarking. From there, you go into what we call different types of surveys. One is a max diff, which I will walk through in detail in a second. A turf analysis, which basically tells us how much a particular value proposition is important to a decision. And then the third is the discrete choice, which really gets you to the ability to say, what is the demand sensitivity for each individual value proposition? And then ultimately, you want to be able to bring all this together into a decision support system so that you can understand and understand the value of each of these pieces and how much they will affect the demand. And what you also want to include the margin, because one thing that you could do in this case is say, just ask a student, what would you like better, a lower cost or a higher cost? If you looked at that just one question, you'd most likely find that everyone would say lower cost. Well, we know that's not true, right? So going through this type of analysis will help you determine how much does low cost compared to other value propositions play into the decision-making process of a student. So let's first take a look at one of the techniques that we use, which is max diff. What this does is it helps you understand of value propositions that you have identified, what's most important and what's least important. And it's important to do it this way because if you start to actually ask people to rank and say, or just say, tell us which of these are important to you, in many cases, they might say all of them are important. And so what we get at by doing this is really understanding what's the most and least important. When you do this over hundreds of times with many different sample results from students, you can really understand what are the trends in terms of what are the most appealing features that you're testing. And so the chart on the right is an example of analyzing results of the questionnaire on the left side here, and saying for different types of student populations, maybe you want to analyze traditional students versus adult learners. What is the most important feature that you tested for those two different types of segments? And in this case, we see an example at the top here. The school offers scholarships. All right, so that's a good one that you would want to test potentially in the next step in this process. And then you can see some other things that you can test. And all of these testing, these items that we're looking at here, you should come up with your administration, your faculty, and your students to say, what should we be testing? What things do we want to know most about? And that kind of that will influence what you bring into these types of analyses. The next one we look at is discrete choice modeling. And so once you get through that max diff analysis, you identify what are the highest influential value propositions. You then can design a discrete choice model, which looks at a number of items. Number one is actually brand. So you can actually look at your brand versus a competitor's brand, and then you pull in all the value propositions that you're going to be testing. And in this example, we looked at things from tuition to fees and scholarships, so all the items around the cost, but then we bring in other value propositions that we know are important based on the results from the previous survey. Looking at industry experience, faculty, accreditation, program modality, which is always becoming an increasingly large question of should we offer this online? Should we have a hybrid? Should we have an immersion, online, but with immersion? Some aspects of career outcomes. What's the employer relationship? Do you have internships? What's the type of relationship to the job market in terms of the outcomes for graduates? And then you can even test things like facilities. Maybe you have a resource question. How much should we be investing in our campus? And how important is that to our students in the student decision-making process? So what you do is you go to market to prospective students, student panels, maybe students that weren't even introduced to your brand, and you ask them to go through these questions. And what comes out of this is a way for you to quantify each of these values and each of and even your brand. And so you can say what influences the decision-making process of a student. And on the right side, you have the results, which basically tell us if we were to just focus solely on demand, right? Looking at the results for a student picking option A or option B, we can see that in this case, scholarship with a $5,000 scholarship, if that was in the student's offer, would actually increase the demand sensitivity for your program by 66%, right? So that's one way to quantify the demand change for potential change for your program if you all of a sudden were able to turn that switch on and say, let's offer a $5,000 scholarship to every single student. Now, one thing you want to keep in mind is that all of these demand sensitivities also you should account for cost, right? To offer every student $5,000, it's going to actually cost you a lot. So if we go to a tool that would allow you to say, okay, if we were to offer every student a $5,000 scholarship, that would reduce the revenue for that program by that amount. So you want to look at not only the start potential or the demand potential, but you also want to take into consideration, can you actually afford to do that, right? So you want to look at margin as well. And doing some simple calculations, you can get at, can you actually pull that trigger to say, yeah, we can offer this because the increase in demand is actually going to cover the cost to offer that scholarship. I'm just sticking with one example. But
Zach, before we move on, may we ask a question?
yes, please.
For the max diff, do you do the survey per institution across many higher eds?
If the institution across many higher eds, is that referring to program, or I guess we can't ask that question, or maybe.
Yeah, let's assume that the question refers to across different types of higher education institutions.
Right. So in many cases, you would do this for your own institution. You would pull the data, as I mentioned, from your competitive set, understanding what are their value propositions, understanding what you want to test for your own. And then going through the max diff is really things that you want to test for your own institution. You then go to prospective students that might be in your funnel currently. You can do that analysis with even current students or recent graduates. And then the third one is trying to find students that maybe don't know your brand as well, but are interested in higher education. And so those are the sample segments that you're looking to get results from. So you have a balanced perspective of first students that are in your pipeline, students that have come to your school, but also students that prospective students that aren't necessarily in your admissions pipeline. And
I think the key there is, and what I heard is, it's institution specific. So you would run this for your own institution, and it can be done for any type of school or sector. It's all specific to the types of students that would be interested in attending a program at your institution, whether that's, you doing it yourselves or using a third party, where we've done this for, trade schools, 1-year trade schools up through graduate schools. So it can really be done at any level and any type of school.
The key here is sample, and getting the right sample to get the results that are relevant to what you're trying to identify. And that starts with just looking at your prospective pool currently today, because you're going to get you have a lot of sample in there. And the question is, you might be able to ask that question to students that did decide to come, ask that question to students that didn't decide to come, and that gives you kind of two different perspectives in that way. So again, this is extremely valuable information when you're trying to understand, where do you invest, what levers can you pull to make your program more valuable to the student, and ultimately win more students, because you're really showing and providing the attributes and the value propositions that they value the most. All right, so I think we'll hand it over to Pete and talk to you about scholarship optimization.
Great. So this really goes a step beyond what Zach just talked about in terms of value proposition and pricing, where the goal of that is to really attract the most students, to try to drive up enrollment. Whereas the scholarship optimization is really focused on what scholarship package should we offer to applicants in terms of being able to not just attract the most students, but that really will affect our net revenue the most, in terms of increasing that total revenue, filling classes at the same time. And so this is where we start to get into some more complex models to be able to do this type of analysis. So there's your machine learning models, which is going to take historical data that you've already got in your systems today, and then some optimization models to try to determine what, again, are the best strategies moving forward. And so I think, a lot of institutions out there are already familiar with these models, and many are using them. And really, this is where you can build it yourself. You can, have some PhD students probably work on these models for you, or you can work with third-party vendors to build these models, where it's ultimately all going to lead to the same outcome of trying to attract the most students for the most amount of money in the end. And really how this all comes together is just like any other machine learning model. You're going to use your historical data in terms of student data on any information you have. And really, this is more than student data, because it should include anyone who's applied to the institution, because you're going to want to also see people who didn't start. How many folks, what did we offer those particular prospect or applicants, and what other characteristics are associated with those particular applicants, and then ultimately, did they or did they not decide to enroll in the institution. So because we're dealing with applications, you will have a lot of data that relates to those particular people in terms of high school outcomes, demographic information, and any other information they would have had to provide through the FAFSA. So you'll have a lot of information on these particular students. And then you'll be able to supply the model with what, again, looking historically at prior years, what did we offer each of those individual applicants in terms of our financial aid package for those students or applicants. And that will allow you to first build out the models to determine what ultimately makes sense in terms of what we did offer individuals. And then you can take those results and run them through an optimization model to test all the different scenarios in terms of what happens if we offer one applicant this much, another applicant that much, and what are all of the different percentages associated with the probabilities of attending, or I should say, enrolling in the institution. And this allows you to then determine what are the best packages that we should offer to each of the individual applicants that we have in a particular semester or particular cohort start period, to try to determine, again, what the most optimal package is for netting out the, again, this is where you need to make some decisions about what the goals are, whether it be a larger enrollment number or a particularly a higher net revenue number, which, again, you can play around with these models to try to determine what's right for you and what different scenarios you'd like to move ahead with based on what the results of these models tell you. But really, this is taking it a step beyond what the value proposition work is in terms of what do we put on our website in terms of what we advertise to attract inquiries and applicants ultimately. And now determining what do we need to offer particular applicants in order to drive up the revenue for our particular institution. And that's really, again, the focus of this is strictly on just the scholarship optimization, but there are other tools, or focus of what we're discussing today. There are other tools to account for similar models where you can build out looking at the other steps once they have enrolled at the institution. We won't be talking about it today, but there are also retention models that you can build that look at many of the same historical characteristics of students, but start to try to identify where there may be students who need more attention in terms of getting through a particular program, or there may be certain even institutional data that you can look at. When two courses are taken at the same time, what leads to higher fail or withdraw rates, so that again, we can focus on students, or maybe tell students not to enroll in those particular types of courses. So there are a lot of other models you can build looking at your historical student, applicant, and inquiry data to try to use that information to make decisions that are most optimal for the institution. And now with that, I'll pass it back to Zach for our next advanced analytics section.
We have one quick question, Pete, if you don't mind, based on what you were just talking about. And it's really more of a comment. Conceptually, one would need to have attributes of the students prior to enrolling, not after. In that sense, data could present some challenges. Would you agree with that? Or do you have any other comments to add?
So yes, that is true. You'll have more data once they're enrolled, but this is really looking at students who have already applied. So you will have data on those individuals in terms of, they filled out an application. So you're already collecting, a fair amount of data for those individuals that have applied. And so you'd want to build the models using that same set of data that you can receive from an application to use that to determine what, again, the optimal financial aid package is for an individual based on those same metrics. So you're absolutely right. You may have less data than you have once they're already enrolled, but you'll have a fair amount of data from the applications.
An example of a data point that you'd have in an application is their location. And so just understanding that a student, especially for regional or more local institutions, a student that's closer by is already more likely to attend. So having things like that will be an influence in the model as well, which is kind of segueing into the location and geographic optimization that you can do. So one question that you might have or you might be facing is, if you're looking at potential satellite campuses, or even you're an institution that are multi-location currently, you can use machine learning and demographic models to be able to identify and make sure that you're locating those new sites, new campuses, regional centers, or other sites in the right place. And so what you use your current data and your current footprint to really understand where your students are coming from. What are the demographics of your students? What's the demographics of the populations that you're looking at, of the markets that you're looking at? And where can you locate that will reach the most students, taking into account demographics, distance, and other population metrics? A couple of things you want to consider is cannibalization, right? So if you're looking to create a site near your main campus or another campus, how much will that actually influence the enrollment to a current location, opening a new location? So those are some things you want to consider. And then in many cases, especially for this, if you're thinking about these they're often commuter type of segment of student. And so distance and drive time will absolutely or typically have a major factor for enrollment. So how do you even go about doing this? Again, it's a lot of a data collection exercise. The US Census is extremely rich in data all the way down to very geographic specific areas. So starting on the left side, the type of data that you would want to collect to be able to build a model that says, if I locate in a new location, how many students would I expect to attract in that location versus a location in the town over? So you want to look at US Census data. You want to understand where your competitors are, and also look at some program and institution specific metrics, like how many times is your institution being searched in a geography? How many times are programs that are important to that site searched in those locations? How does the employment influence the demand for your programs in your institution by location? So those are types of metrics that you want to include. The US Census also will have hundreds of variables from population, demographics, ethnicity, household income, and many different data points that could be helpful when doing this modeling. So what are you trying to model in this case? Typically, you're trying to model starts. how many starts or students will enroll based on having a specific location. So you first want to identify, do I want to model starts? Do I want to model actually maybe graduates? Or do I want to model something else? Right. And in that case, in many cases, as long as you have something, you can actually probably model all three of those and do some sort of assembled model that would say, okay, in this location, we would expect the start model to produce X number of students, the graduate model to produce X number of graduates. And it gives you multiple points to say, yeah, we're pretty confident that we should locate here versus somewhere else, right?
Zach, can I interrupt you for another question, please?
Yes, please.
Sure. Are there potential ways to analyze cannibalization of new programs with similar models?
The cannibalization of programs is a very interesting question for multiple reasons. One is it's very hard to get at. One question that we always find is, okay, if I offer this new program, is that going to increase the number of students or just change the, just spread out the number of students over multiple location or over multiple programs? There's a few techniques that we use to actually get at that. But not specifically machine learning techniques at this time. But if you've identified something, we'd be all ears for that. An example of that is to look at launching your historical view of launching programs internally, and did that change the increase enrollment? You can look at examples using the iPad's completions data at other institutions when they launched a particular program. Did it actually increase the number of graduates? Or did the number of graduates cannibalize other institutions? So those are some techniques that we've used, but not necessarily using demographic machine learning models to answer that. Okay. So again, what you're trying to get to is understanding and visualizing new locations based on the demographics of those locations, the proximity to populations that meet the demographics that are typical for your program, to ultimately be able to say, okay, where are the best locations for a satellite campus or a new campus or a regional campus? And taking into account, is there opportunity to put multiple locations? And again, taking in a cannibalization, an easy way to do that, that's not too an easy way to look at that is just proximity from location to location. So if you would just assume students will go to the nearest campus, that's a pretty good rule of thumb for understanding cannibalization. There's more advanced techniques, but that's a much easier and quicker way to do that. Some other things you want to consider: competitor locations, convenience to the location. So these are things that come after the modeling, but you want to keep into account, right? Once you get once you get the results from the model, you can then go to your real estate firm and say, here's the areas. And if we locate, 20 miles south of this area, we're still within 10% of the maximum of the model, and we're okay with that trade-off. So understanding those trade-offs is also helpful. With this same type of modeling technique, you can understand, where do I want to recruit for students? Where do I want to spend marketing dollars? So you can be more efficient with your marketing. So instead of looking at starts, maybe you want to look at lead opportunity by market and understand if in a certain market, maybe you want to do this by zip code, for example. In a particular zip code, what does the population look like? What are the demographics? What's the median household income? What's the percent that have an associate's, bachelor's, master's degree? All of those same demographic variables that you might use that I was mentioning in the previous model can be leveraged in a model like this to understand, first, what's the opportunity in terms of a potential opportunity by zip code, but then how much might I need to spend in each zip code to realize that opportunity? For example, a marketing dollar spent in New York City is not equal to a marketing dollar spent in Cincinnati, right? It's just going to be completely different. So you can't automatically say, okay, there's these two populations, and I'm going to spend the same amount and get the same results. You actually might get a lot better results in Cincinnati because it's going to cost you a lot less to market there. So bringing in both leads and spend, your historical spend, you can build a model that will ultimately allow you to identify where is there opportunity, and then what spend level do I need to reach in order to realize that opportunity. And so here's a look at a potential output. If you looked at a particular geography, whether that's a zip code, a county, or city, however you define that, you say, based on your historical results of spend and lead volume, what would the model say for a particular geography if I spent $1,000, $5,000, $10,000, $15,000 per X? Maybe that's per term, per month, per year. And what would I actually reach in terms of lead volume? But what you ultimately want to do is get a cost per lead ratio, because that will give you an efficiency, right? And so where you can reduce your cost per lead while also meeting your lead volume expectations is where you can be more efficient with your marketing dollars. So switching gears to more of an academic focus, advanced analytics techniques that you can use is looking at skills, trends, and gaps. And the questions that we often see and we think about ourselves are, what skills are needed in the workforce? Do those skills align with what I'm teaching? In my curriculum, what am I missing? Whether that's trying to ultimately provide the education to students so that they're more employable graduates. And then ultimately, the other thing is, okay, well, maybe I don't have a program that fits that type of curriculum. So it could even inform new programs that you should consider. So going back to the trend is, what data can we collect to help us answer this type of question? Go to this next share. And ultimately, you want to look at many different data sources, right? And they'll all give you different types of perspectives and trying to find. So there's a lot of information. One of the most useful is job postings data, understanding what employers, who's in the market, what jobs are they posting, what skills are they looking for, and a lot of them even now are posting the wage as well. So it can give you a lot of rich information that way. We also look at from the employer's perspective. Another area you want to potentially look at is from the student perspective, right? And a really rich data set that you can look at is the MOOC data from Coursera or Udemy, and really understand where are students enrolling, because it gives you a pretty good first indication of the types of skills they're even looking for before they might go to a full program, whether that's a certificate program or master's or any other award level. If you really want to look out in the future, look at funding sources. DARPA is one of the biggest funding for government projects, looking out into the future, saying where is the government thinking and putting money and investing in research. And so that's another example. And then publications, absolutely looking at the future of work, the World Economic Forum. These are all rich data sets that will help you identify what are the skills trends and what might be coming in the future in terms of needs in the job market. So one technique that you can use to compare your programs and your curriculum to the job market is to align your programs and your curriculum based on your course descriptions, your syllabi, to what employers need in the market, and to understand where there might be a gap based on what you're providing and then what employers are looking for. One technique you can use in this case is using natural language processing to align the curriculum to a skills taxonomy that you then can compare to the skills that are coming from job postings data. So it is a pretty complex process. again, as Pete mentioned, you might have people on at your institution, whether that's within the data science department, PhD students, or the like, that could work on models like this to really help you understand what are you providing and where are you covering from a program and course perspective, and then how is that aligning with what employers are looking for. Aligning both of those into a skills taxonomy that you can then identify where there might be gaps. And so again, using more of an advanced technique of natural language processing can help you get at that type of skills gap analysis. So we'll switch gears and a change of voice to Youssef to talk about another technique to help predict program size.
Thank you, Zach. So another application of advanced analytics when it comes to higher education is predicting the size of a specific program at a specific school. Just imagine the value that would come out of answering this question on the slide. How big is a program likely to be at my school? This could be a new program or a current program that you're evaluating as well. Knowing the size of a potential demand is one of the golden questions that get asked in businesses and whatnot, and it's not less important in higher education. It's actually very important in planning, in evaluating, and in budgeting. Next slide. So when you look into evaluating, you have to keep in mind, like, you're looking into what is a little bit more than 1,500 programs. So picking one of those programs means not picking another 1,499 programs. So the opportunity cost is really high. So having an idea of what a potential size of that program will be at my own institution gets to be very important. Let's say you pick that program and now you want to plan on launching it. You can rely on your previous experience. I mean, nothing wrong with that. However, it may be risky because you don't launch a program every day. So things may be outdated from the last time you did. The programs may be different from last time. So just having the size of that program coming and kind of anchored in the future, this is what you can expect as a potential size, can help you put things in place into planning and into budgeting as well. We're talking about faculty, we're talking about facilities, housing, marketing. We have is the outreach strategy that you planned, is it enough to capture that size, or is it too much? And this is where the knowing when to stop comes in handy. Let's say, for example, you estimated that you would have 30 students joining every year, and every year you keep getting about 12 to 15. So you keep putting more money into marketing, you keep putting more money. So knowing when to stop is like, is it actually 30 or is 10 to 15 the right number for you? So this is all because you don't have unlimited resources. So what you see on the right-hand side is kind of a waterfall graph where when we anchored a predicted size for a specific program at maturity in year 4, we were able to trace back both the enrollment and the revenue all the way to year 0 of launching a new program, as an example. To create this program, to create this model that would predict a program size, you just need to consider what data is out there and what is the kind of the conceptual model in mind before starting putting into kind of coding. So the first thing you have to keep in mind, like, completions is the most complete data. We don't have enrollment based on institution and a program, unfortunately. However, completions coming out of IPIDs is the most versatile out there. It gives you what is the size of a completion at school all the way back to like 10 years or even historical. So you would have more historical idea. We'd also look into the market data, talking about the student demand and employment and how are those affecting. And when you get to an idea that you want to implement, you will end up actually engineering some factors that are not jumping out from the data. So you have to put some thought into it. So an example of one model that predicts program size, what you see, this is the input for it. The school size, how big is the school? That comes in total completions of the school, the median completion, the average completions. What is the size of another award level? For example, when modeling a master's, it would be helpful to put as an input, what is the size of the bachelor's? Program size at a similar school, Zach mentioned earlier, peer institutions and competitors, if they have a program that you don't have, how big is it there? And would that be a good indicator? It turns out that yes, it is. Program size nationally. And this is gets an interesting in kind of story here. If the program has 20 institutions offering it nationally, and the maximum number is 10 completions, then an average size school may not expect 55 completion out of that program. Just the actual size of the program across all the nation, it comes in as a good indicator. The school characteristics come in play as well. Things like what sector you are in, what is your selectivity, what is the demographic mix you have, they also play. What is your portfolio fit or the institutional fit to offer that program? An example that I like to give here, like a school that is very strong in healthcare programs, but never had an engineering program, will get less predicted size for an engineering versus healthcare. And lastly, as I mentioned, some market data also help. When you get all that data, curated, filtered, and cleaned, which, by the way, you might have heard that before, it does take over 85% of your time. Now you get into the actual modeling, and the machine learning comes in place. Okay. So taking that data, putting it into a model, sounds simple from the graph. However, I'm going to give you some tips on what to kind of keep in mind about machine learning. There are a lot of issues that are so easy to get into. One of them is being a tautological or creating a tautological model, or something that they like to call a data leakage, which basically means you're giving the answer to the model before it gives it back to you. That model will give you a 99% accuracy, which is not necessarily a good thing. If you get anything really high, there's an issue with the model. These are some of the models that come in, useful: gradient boosting, XGB regressor, which usually proves to be very strong, and random forest, but there are a lot others. There's dozens of models out there that can be used to predict a program size. Now, how to evaluate the model output? You can evaluate it by number. However, we found that it's not necessarily the right way of evaluating it. But the better way is to actually optimize on minimizing false negative and false positive. And by doing so, advanced analytics can actually get you over 90% accuracy. So let's take a quick example. Let's take a quick look at the slide, at the graph at the bottom left. This is a sample of large programs. And what did the model predicted out of? So it says 77% of those large programs were predicted as large, and 19% were predicted as medium, where 3% were predicted small and very small. This is where the optimization come in very handy. These 3% are, kind of misoptimal. Like the model told you it should be small or very small, but it's actually large. So this is 3%. This is where you're optimizing to minimize. And at the same time, on the right-hand side, it's a very small program, and it's only 2% that the model told you, oh, it would be medium or big. So this is kind of avoiding to tell you a bad program is necessarily good in terms of size. A few things to keep in mind. Next slide. There are some limitations, just like anything else. The enrollment. What we model, as I mentioned earlier, is completions. Completions are easy to model because they exist. However, enrollment does not. And every school has their own multiplier for every person or every student that graduates, how many students are actually attending at the same time. This multiplier ranges depending on the award level from 2 to 4 to one school that has a multiplier of 12. So knowing your multiplier comes in handy. This goes into the attrition and the retention. They all play a role into determining your multiplier. The maturity, you cannot model on immature programs. Otherwise, you're modeling for you to bring you out what is the size of the mature program at your institution. So knowing the maturity is very important. It could be 3 years, could be 5. It depends on the school. It depends on previous conversations at the planning. Cannibalization, we talked about this earlier, so I'm not going to go much into it, but it goes back to, if I started a new program that is predicted to be large, will it transfer other students from my other programs to it, or would it be in new programs, new students from coming from outside? So the idea here that I like to give, and an example, if you offer a program that took students from your existing programs, is that better than other school offering the same program and taking your own students? So think about, would you cannibalize your own students, or would like others to cannibalize your students? Modeling limitations. Every model has limitation. Every data set has limitations. I heard before saying, there are two types of data that has issues and data that you still don't know that has issues. So you have to keep in mind that of what are the issues and what are the caveats, the outliers, and how to deal with them. And lastly, what I mentioned earlier, the size category versus the number. In terms of prediction, you can predict the number and it comes out, and it may not give you what you actually want, versus the category can put you in the right direction a lot easier than the actual number. Now we're going to Pete.
Great. Thank you, Youssef. So our next and final section is called Predict Margins. And this is really now focusing on the financials of programs as well as the institution as a whole, which I'll touch on. In order to put this all together, the first step in the process is really building out the historical data so that you can use that information to incorporate it into a model to run predictions on different scenarios and strategies, really. And so this was really covered in the last masterclass that Steve walked you all through in terms of how to build out the historical analysis, where you're ultimately calculating down to an individual section how many students were in that a particular class, what they paid, what they discounted, and what it costs to teach those individual sections. And then separately, a bunch of other metrics you'd have relating to those individual sections, so that you'd be able to calculate historically what the individual economics for a class are, for a course, for a program, for a department. And then you take those results, and that gives you your what is analysis, as we refer to it here. And then essentially you take several other numbers, like your potentially your predict program size outputs, to be able to apply those numbers to a table and see, if we hit certain targets, what might our economics look like if we were to hit all of the enrollment calculations or estimates from that model. We could put targets in there from our deans in terms of how many students we believe we'll have for a particular program or set of programs within a department, and basically run those through a model to produce the what if analysis. So if we add 10 students to nursing, what does that mean for our overall economics? And what does that mean in terms of number of courses we need to teach and faculty we need, and so on? So it's really, there's a lot of information you can get out of this. The other piece of that I'll mention too, that's extremely helpful in not just the model here, but that you can also use from the data that Youssef walked you through, is that last class that Steve went through included benchmark information. So one of the other unique aspects of that analysis is in having benchmark data as it relates to revenue, cost, and contribution for an individual program. That allows you to see for new programs what our economics might look like when it's operating at a steady state. Because the model predicts where our current program should be, but also for any potential new programs, what the size might look like, but it doesn't offer an output for the costs or the contribution. And that's where having the economic data from benchmarking institutions in a benchmark sample can be helpful for modeling that out as well. In terms of how this particular model works, it's really, the calculations are done at a very detailed level. So focusing on the table in the center of the page here, you've essentially got all of your programs growing across the columns from 1 to 12 in this example. But imagine, at any institution, this could be 100, 200, 300 different or unique programs that are offered. And then you've got your courses down the left in the first column, which this could equal, 1,000 or more potential courses that you all are offering at your particular institution. And so we've got a giant matrix where this is, this looks like it's an Excel, but this would have to be, the data would have to sit inside a system that is not Excel to be able to even export the data required to go into a model like this. And then ultimately what's happening is the calculations are running through. We can see shown at the top here are, this is how many new students we're gaining or losing in a particular program. So we can see if I pick on program 4 for a second, we're subtracting 30 students from that program. So whether this is, we're expecting it to decline, or they're looking at what the economics look like if we decide to stop a program entirely, or it's, the market's declining, we can put a negative 30 in here. And what'll happen is that'll flow through all of the individual courses that students in that program typically take. So that's where having the historical data to see that students in program 4 typically enroll in AN 111, Art 155, and several other courses throughout this particular list here. We'll be able to see what the economics look like if we strip out 30 students. So now we're seeing ultimately what the overall economics look like for our individual course levels, and that'll help us determine for the next semester or year where we may be over or understaffed based on these calculations that are all based on potential program inputs. And so this is where you can start planning for next year in terms of, if we're to grow our programs, we want to invest in growth. Where may we need to add resources in terms of, in particular, instructional costs? If programs are declining and continue to decline, what particular departments or subject areas may we need to subtract potential headcounts? And which in effect is really subtracting the number of classes we're offering. So this is where you can run these numbers through this model to try to help make some of those planning decisions. And what that looks like in terms of the some of the outputs that you can see from this is, this is an example where, this is a fake institution, but we're adding 10 students to math. And so we're able to see what that means is we've added roughly $211,000 in revenue, but we didn't have to add all that much in costs. Looks like it's probably an independent study or something, because we didn't actually have to increase the number of faculty, because our courses in this particular example weren't operating at full capacity in terms of the section fill rates. So while we added 10 students, we didn't have to add any faculty to teach those 10 students. So, this just gives us some sense of, this would be positive to the overall contribution to the institution as a whole in the amount of $211,000, because we didn't have to add a lot of capacity. Alternatively, if we wanted to subtract students from a particular program, again, not real data, but this is where you'd be able to see now that we're subtracting students. If we wanted to decide to cut a program because it's small, we can see how that affects the institution's financials as well, in terms of what we lose in revenue if those students weren't to enroll in a different program, which is another aspect of this analysis. And then ultimately what we save in terms of costs if we are to remove, in this case, 13 students, or this program declines by 13, we don't actually save a whole lot in costs. So it might not be the right decision to cut this program, because it may be that we have to keep a lot of the courses that we're offering because they're being used in other programs. And so there's not a huge potential savings that is seen or experienced by making or by this program shrinking, or if we cut this program entirely. So that's kind of the program level focus of all of this. The last really piece I'll mention is that this can then be filled into a much larger planning model, where one of our colleagues that been working with, Bill Massey's, really built this out of a more strategic planning model to take a lot of these inputs at the very detailed level, like course level inputs that we were just talking about, and then adding in the rest of the institutional overheads to see how, maybe potentially a curricular efficiency strategy plays out across the overall institution's financials. But by having a larger planning model, you're able to see, how changes across the institution as a whole will affect the overall profit or loss for a particular or for your particular institution. And so this is where you can really build out, and this would take a lot more time than we have today, but this is kind of just in here as more of an intro to really share with you all that these planning models can be extremely helpful, and they do exist, and allow you to see in certain market scenarios, what happens if we don't enact any particular strategy. If we have another, market decline and the endowment doesn't grow as much as it has in prior years, what does that look like to our overall cash flow? Or alternatively, in a good market, how much runway does that add in terms of the institutional surplus? So there's much larger models that you can build where you can test out different strategies, like growing programs, investing in marketing, but also run through other strategies like the scholarship optimization if we adjust our discounts, or if we add athletic teams, invest in marketing, increase our third party spending on different vendors, whatever it might be, or build out dorms. What do the economics look like for that, and how does that affect the overall institution's economics? And so with that, now that we're down to our final 2 minutes, I'll just flip to what's next, and our final, before we open it up for any other questions in the last minute, we do have one more masterclass, the fourth one, which is on the future of academic program portfolio evaluation and management, and that'll feature Bob Atkins and Rachel Chung, who is an associate clinical professor at the School of Business at College of William and Mary. And that'll be, I believe, same time next week. And then lastly, just for more resources from Gray in general, there is a course on academic program evaluation that goes into a lot more detail than we had time for today. But this, certainly in the other classes, provide you with much of the introductions and some of the groundwork for how you build out some of the tools necessary to do program evaluation and much more, as was demonstrated today, plus some other webinars on demand trends. And finally, there's Bob's book, our CEO, who wrote a book called Start, Stop, or Grow, which is available on Amazon, which again really dives into the academic program evaluation and management and all the data and processes that go into that. So with that, I'll open it up if there are any more questions. But for those of you still out there, we appreciate your time, and thank you all for joining us today. And please feel free to reach out if you do have any questions, but don't have a minute or two to stay on.
Pete and Zach and Youssef, I'd like to draw your attention to the Q&A where there are some questions popping up.
Okay. So this one is for you, Youssef. If a program is smaller than predicted by the model, how do you know if it is a problem with the model or with how the program is implemented at your institution?
That's a good question. So the latter part with your question of how the program was implemented is things that cannot be tracked historically. So we don't know. It could be as, an idea like, oh yeah, you put zero into marketing, or, oh yeah, there was no faculty to do advising, so the student weren't actually encouraged to join the school. So these factors were not factored in the model, they were independent from it. However, how would you know if the problem is in the model? There are kind of other manual checkpoints that you can do when you create the model and see kind of if the number you got is way lower than others or way higher than others, that's like screaming outliers.
And I will just add this is one data point in many data points that you should have when especially launching new programs. Once you have this, it helps you budget for the new program, but you should still go through a program launch process, which would include identifying your competitors, identifying the value propositions, and all the pieces that align with that so that you do have a successful program. What this model does is saying, assuming you do the same exact thing that you do with all your other programs in terms of marketing and missions and faculty and things like that, this is what you can expect to get. So it's not telling you, just launch this and it's going to be like this. You still have to go through the normal, launch process to be successful.
Great. Well, with that, I think we'll end it. If we'll answer any other questions via email or can hop on a call. So feel free to, if you haven't added anything to the chat, to email any of us, which you can find at all our contact info on our website. So again, we thank you all and have a great rest of your day and week.
Thank you, everyone.